Okay, these notes are chemical reactions. The process by which the atoms of one or more substances are rearranged to form different substances is called a chemical reaction. A chemical reaction is another name for a chemical change. Now, when you have a chemical reaction or a chemical change, there should be some sort of evidence. Evidence that a chemical reaction might have occurred is as follows. Now, guys, this is might have occurred. This doesn't mean it actually happened, but if you get like 2 or 3 of these, most likely a chemical reaction did occur. So you got temperature change, color change, odor given off, release of a gas, and formation of a solid, otherwise known as a precipitate. Once there has been a chemical reaction, scientists need a way to represent the chemical reaction. Chemists use statements called chemical equations to do this. A chemical equation uses symbols to represent the materials in a chemical reaction. Okay, let's look at chemical equations. Chemical equations show a reaction's starting materials, called the reactants, and the reaction's ending materials, called the products. An arrow is used to separate the reactants from the products. It also tells you which direction the reaction is going. Could be from left to right or right to left, depending on the arrow. Okay, the reactants are written to the left of the arrow, and the products are written to the right. So you'll have your reactants, which are the starting substances, or starting materials. And then you'll have this arrow, and then you'll have the products. And this is generally the way it works. So ending materials. Every once in a while, the arrow will be going the other way. And then the reactants would actually technically be on the other side. But a lot of times you'll have, if it's going to the right, it also goes to the left. So you'll have a double-ended arrow. And that means it goes back and forth, but we'll get into that at a later date. By the way, the arrow means either yields or produces. Okay, so hopefully you understand that. So a plus sign is used to separate 2 or more reactants or 2 or more products from each other. Okay, let's look at this one. Hydrogen and oxygen react to form water. So when you see that "and" in there, that means we're going to put a plus sign. So the reaction written as a chemical equation looks like this. So you have your hydrogen, and your, why did I put the 2's there? H2 plus O2. Something called Hofsprinkle, if you remember that. So anytime we have hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine, we have to write them as a diatomic. Remember, those are the diatomic molecules. So you'll never find hydrogen by itself. So it's H2 plus O2. And then it yields water, forms water. Okay, that's the H2O. Now, this equation is not balanced, since there are more oxygen atoms on the left side than on the right side. So if you look here, we've got 2 H's here, 2 O's here. We have 2 H's here, but only 1 O here. So it is not balanced. The correct equation, or the balanced equation, looks like this. It's 2H2, so now we have 4 H's, plus O2, giving us 2 O's. Whoops, you know what? It's not balanced. There's supposed to be a 2 there. Typo, so it yields 2H2O. So now once again we have 2 times 2, so 2 times 2 is 4, 4 H's, and then that 2 also goes for the O's, so there's 2 oxygens. There's 2 actual waters. See, it's HOH and HOH. So that gives me 4 H's and 2 O's, okay? So make sure you put that 2 in there in the guided notes. I don't know if I left you a space to write that in or not, but it has to have a 2. So now the coefficients, which are these things, these are the coefficients, in front of each substance, in front of each, change that word to chemical formula, indicates how many of that particular substance is involved in the reaction. It's also not a good way of writing chemical. I can't spell today. Okay, so it's in front of each chemical formula. Indicates how many of that particular substance is involved in the reaction. Now, sometimes the states are given in a chemical equation. So if you see an S, that means solid, L is liquid, G is gas, and AQ means aqueous, which is dissolved in water. Okay, some examples. If you see H2 with a G next to it, that's hydrogen gas. Hg with an L next to it, that's liquid mercury. NaS, solid sodium. NaCl with an AQ is aqueous sodium chloride. That means the sodium chloride was dissolved in water. Okay, let's write this in words. That's supposed to be, so I'm going to go ahead and change this because that's supposed to be a little 2. So write that as Cl2. Okay, so when you write this in words, this is solid. Here's our solid, sodium. So solid sodium. And you do not have to write the coefficients. Okay, we're just describing what's going on in the chemical reaction. We can't see the atoms of sodium, so we don't need to write 2 atoms of solid sodium. We just have to write solid sodium plus, or you can write reacts with, doesn't matter, plus chlorine gas. And I'm going to put in parentheses under here, reacts with, because that's another way of stating it. That's another way you'll see it stated. Okay, produces, or yields, I like the word produces, sodium chloride, solid sodium chloride. Pretty easy, huh? So all we're doing is we're describing the reaction. We're going to put this, the chemical equation, or the chemical equation into words. So solid sodium reacts with chlorine gas to produce, or produces. So if you're using the reacts with, you're going to have to say to produce. Whichever makes more grammatical sense, I guess you could say. So solid sodium plus chlorine gas produces solid sodium chloride. Hopefully that's pretty easy. But that's all there is. Tomorrow you'll have some questions on these notes. And so that's it. Have a good night. Bye.